Yeah. Of the very famous One of the very famous scientists, Richard Swart, had said that the impact of nanotechnology is expected to exceed the impact that the electronic revolution had on our life. With this note, a very warm and pleasant morning to one and all present here. Myself, Poonam Bajoria, welcoming you all to the IEEE Summer School on Nanotechnology 2024, based on the theme Artificial Intelligence and Internet of Things in Nanotechnology towards Digital Agriculture. The, the IEEE The IEEE Nanotechnology Council Student Branch Chapter IIT Indore was formed on March 23rd, 2021 under the guidance of Professor Saibal Mukherjee. The NTC Council is a multidisciplinary group uh, which promotes excellence in the field of nanotechnology by enhancing the quality of life for humanity through its members' contribution in the translational R&D, manufacturing, and application of nanotechnology and nano devices and systems. The IEEE NTC student chapter is actively involved in the technical domain by organizing technical events such as distinguished lecture program, mini colloquia, sponsoring and co-sponsoring various conferences, webinar, workshops, membership drives, opportunities to network with peers, the resource center, environmental awareness campaigns, and promotional activities with the objective of sustainable developmental growth. The members of our IEEE NTC student branch chapter are thriving to create an interactive platform for young professionals like academians, scientists, technologists, and engineers to discuss, explore, and collaborate in domains of semiconductor, nanoelectronics, photonics, optoelectronics, photovoltaics, biomedical sensors, and memory devices. We have been organizing around 15 events per year, which are beneficial to students as well as young researchers to broaden their horizon of knowledge and skills. Our team has also been honored with the well-deserved prestigious IEEE Outstanding Branch Counselor and Advisor Award for 2023, the Darren Chung Student Activity Award, and many other various prestigious awards and recognitions. We encourage the students and all the interested members to join the IEEE NTC Student Branch Chapter and get benefit from all our endeavors. The summer school program on the artificial intelligence and Internet of Things in nanotechnology towards digital agriculture aims to provide a platform to participants to learn and apply specific skills of AI and IoT in agriculture from leading experts of industry and academia. Apart from the lecture sessions, sophisticated lab visits as well as field visits are planned, which would help in learning new skills and knowledge about the best practices in modern digital agriculture. Our main objective is to create an ecosystem for research, innovation, skill development, and entrepreneurship for research, innovations, and to train the participants to adopt modern trends and practices for its application in agriculture for achieving the goals of sustainable development. To start with the event, first I would like to request Mr. Mayank Dubey, Chair IEEE NTC Student Branch Chapter, to come and inaugurate the event by sharing your motivating words. Sir, please.
Good morning, everyone, and thank you, Poonam, for such a nice introduction to our IEEE Summer School on Nanotechnology. I welcome you all on behalf of our team of IEEE Nanotechnology Council Student Branch Chapter at IIT Indore. So today we are basically hosting the summer school on the nanotechnology field. This has been given by the Nanotechnology Council of the IEEE. So, just to give you a brief glance about the IEEE is a society which has over 4 lakh members across the world in 160 nations, as you can see in the slides. And of that, more than 1,25,000 are the student members. And that is the basic idea that we wanted you all to join today and get the idea of IEEE and get the idea what new technologies and the cutting edge research is going on across the world. And we have several our guests and delegates speakers present over here who will be basically presenting their research work and discussing with you all, and you will get a brief idea that what research at currently in India at the national level as well as in the international level is going on. So that is the main objective of this summer school on nanotechnology. The IEEE has more than 300 sections across the 10 geographical locations you can see in the world map. And India lies in the Asia Pacific region, which is also known as region number 10. And of those, there are 2,615 chapters, of which the chapter of nanotechnology at IIT Indore is one of that. And here I would like to just show you a short video on the IEEE to give you a glance about the complete presentation.
And vision for the future are simple and profound. Our mission is to foster technological innovation and excellence for the benefit of humanity. Our vision is that we will be essential to the global technical community and to technical professionals everywhere, and be universally recognized for the contributions of technology and of technical professionals in improving global conditions. 6 core values support our mission and vision. Trust, growth and nurturing, partnership, service to humanity, integrity in action, global community building. To accomplish the goals in our 2020 and 2025 IEEE strategic plan, IEEE will drive global innovation through broad collaboration and the sharing of knowledge, enhance public understanding of engineering and technology, and pursue standards for their practical application. Be a trusted source of educational service and resources to support lifelong learning. Provide opportunities for career and professional development. Inspire worldwide audience by building communities that advance technical interests, inform public policy, and expand knowledge for the benefit of humanity. IEEE will foster a collaborative environment that is open, inclusive, and free of bias, and will continue to sustain the strength, reach, and vitality of our organization for future generations.
So with that, I just like to bring to you some of the glance of the activities that our society, our chapter at IIT Indore has already organized. Although we have covered more than 70 plus events in the past 2 years of our basically here at IIT Indore, but just you can see as I in the slides in the video you have already seen that IEEE is not about the technical or just the innovation society. It is also working for the humanitarian grounds and for the benefit of humanity. You can see in the scientific social responsibility 2023 that we organized, we have covered such aspects in our chapter, and going forward with that, there are various awards. For example, you can see in the slides, we have recently won the Outstanding Branch Chapter Advisor Award, which has been awarded to Professor Shabal Mukherjee. And you can also see the volunteer awards, which has been granted to Dr. Pavan Kumar, to Mr. Mayank Dubey Chair, Mr. Sumit Kumar Chaudhary, who has recently got the Nanotechnology Council travel grant of this society as well. So all these are the benefits that you can go through with the website, if which I will share you at the later stage. These are all the glances you can see. And with that, I would like to give the mic to Poonam and would like to request you all to please proceed with further with the event. And thank you all, and I welcome you all again. So good morning again. Okay.
Thank you, Mr. Dubey. Now, proceeding further, I would like to invite Dr. Sushil Kumar Pandey, Assistant Professor, NIT Suratkal. Let me throw a light on the bio of Dr. Sushil Kumar Pandey. Dr. Sushil Kumar Pandey is an assistant professor at NIT Suratkal and currently serves in the Department of ECE. Before this, he had held positions at the Institute of Infrastructure, Technology, Research and Management, Ahmedabad, and the Indian Institute of Information Technology, Una, Himachal Pradesh. He has done his PhD from IIT Indore. His expertise spans semiconductor thin films, semiconductor light emitters, photovoltaic devices, photodetectors, and two-dimensional materials. His academic journey includes impactful roles as a postdoc research associate at the University of Minnesota, Minneapolis, and a postdoc research fellow at IIT Bombay. Dr. Pandey's passion lies in the TCAT simulation and the design of electronic device. Sir, the stage is all yours.
Very dear. Okay, so good morning to all of you. Thank you, Poonam, for a nice introduction, and thank you, sir, for inviting me. So my name is Sushil Kumar Pandey. The detailed introduction is told by Poonam. The topic is 2D materials-based devices for smart agriculture, scopes and challenges. So the thing is, whatever I am doing presently, that I will try to connect with agriculture. So basically, I am working on 2D materials, and these devices, how these devices can be used for agriculture, that I will try to connect. So we can see here the outline of this presentation is about, first I will discuss about introduction of 2D materials, and then advantage of 2D materials, and what are the recent progress in 2D materials for various applications. And then we will see 2D materials for smart agriculture, how we can apply them for agriculture. And then we will see a little bit details about the growth part of 2D materials, like when it tungsten diselenide and fabrication of FET, and black phosphorus fabrication and their passivations, and summary of presentation. And in last, we will see work opportunity in this area. So these things we will cover. So my focus will be towards material development and device development. Then followed by me, Dr. Vivek will focus on IoT-based devices, how we can apply IoT in agriculture, and overall infrastructure will be discussed by Rohit Singh. So what are 2D materials? First, you may have uh, listened about silicon, germanium and all. So those materials are 3D materials. So what are so special about these materials? So as the name suggests, two-dimensional materials. So two-dimensional means these materials are basically atomically thin materials. They have big interlayer van der Waals forces and strong intralayer covalent bonds. Like in this one, you can see, for example, take tungsten diselenide. You can see here within one layer, the bonds are covalent in nature. But if you go between two layers, if you see, there is no physical bond. Okay. So these materials are basically grow layer by layer, and between two layers, there is no physical bond. So it is easy to cleave them or exfoliate them. Okay. Similarly, another example is phosphine. You can see the bonds in one layer, they are covalent in nature, and there is another layer, but between two layers there is no bond. So they are together due to van der Waals force between two layers. Sir. This pointer actually, okay. Pointer, how to operate this? No, that is for, but that is to change the slide. There is. अच्छा अच्छा छोड़ो छोड़ो कोई इशू. So now these materials, as we discussed, that they have two-dimensional nature, and because there is no physical bond between layers, so they are soft material basically. Okay, and there are different members in this family like graphene, boron nitride, transition metal dichalcogenide, black phosphorus, and they have various applications. Few fancy applications like flexible electronics and transparent electronics is shown here. Now we will focus basically this transition metal dichalcogenide. Why we want to focus this family? Because this family has potential for sensors for agricultural field. Okay, like you may have heard about nitrogen, phosphorus, potassium sensors. So these materials are very suitable for that. So therefore, we will focus on this only. So if you see this subfamily, they have formula like MX2, where M is transition metal and X is chalcogen atom. M means it can be molybdenum, tungsten, etc. And chalcogen like sulfur, uh, selenium, and tellurium. And how to develop these materials? So basically, a technique is used that is called chemical vapor deposition technique. This is very famous technique to develop these materials. Now, before going in details how to grow them, and these materials has some advantages that we can see here. So like they are very thin in nature and they are lightweight materials. If you use them for some ion diffusion, they can give you fast diffusion. Remarkable electron conductivity they can give. So some devices which want high conductivity, high electron conductivity, there you can apply them. And they have high thermal conductivity also. So there are some devices where thermoelectric properties are needed. So there we can use them. Similarly, for gas sensor applications, we can use them, and they have high mechanical properties yet flexible. So these materials are basically flexible, and we can use them where some flexible devices you are prepared. One is where we have application for flexible devices. Then we can do some defect engineering also in these materials to tune the properties of desired device. And they have high surface interaction, so that we will see in detail. Okay. So we can see here the what are the recent progress in two-dimensional materials for various applications. So first of all, we can see they can be used for chemical sensing. Why they can be used for sensing purpose? Because they have high surface area to volume ratio and ultra high surface sensitivity to the environment. Okay. So due to their high surface area to volume ratio, they are suitable for fabricating different sensors. For agriculture point of view, if you see, we can use them to fabricate nitrogen, phosphorus, arsenic sensors, and pH sensors and humidity sensors and temperature sensors also we can fabricate. So basically, whatever agent you are applying on these materials, they are getting large area to interact with this material. So therefore, they are suitable for that purpose. Other applications also we can see, like they are used for the solar cell applications. So they are good for a solar cell application and photocatalysis catalysis process. And they can be also used for optical modulation. So these are the few things which people can do except the sensor fabrication. Okay. Now we can see here this they are also suitable for field effect transistor fabrication. We can achieve very high on-off ratio in this case. And again, we can see here, if you want to tune the property of solar cell and its efficiency, they can be used as interface materials. So these are few recent things people are doing in this materials on this material system. Okay, like we have discussed, mostly they are used for sensing application due to high surface to volume ratio. So because they have large surface to interact with any foreign agent, so they are suitable for sensor application. So we will focus how they are useful for nitrogen, phosphorus, and potassium sensors, and pH sensor, and humidity and temperature sensors. All these things. Okay. So these are the few things which people are doing in this area. Okay. Now we can see what are the smart sensors for agriculture. Briefly, I am telling you, like if you want to use you want to do smart agriculture farming, you need humidity monitoring and temperature monitoring also. You can see here, and soil quality monitoring is needed here. And then we can see plant disease monitoring is needed. Crop production assessment also this is needed. Pest monitoring is needed. UV waste surveillance is needed to check the quality, to check the health of plants, and also the how they are growing, that is also can be assessed by crop growth monitoring. Okay, so basically these two are interrelated. Okay, so these are the things. These types of monitoring is needed if you want to do smart agriculture. So our focus will be this one, and this one, sensor part. Okay. So humidity sensor. Okay. So humidity sensor, basically in this one, we use different type of carbon based material for this purpose. Okay. So you can see here very simple structure is shown here. Okay. This is sensing layer. Basically we use graphene most of the time, and there are contacts both side. Okay. Now, if you see the process for this, it needs actually some type a substrate, and then aluminum deposition, then anodization in electrochemical setup, and then electrode deposition, and finally this type of device prepared. Okay, so the thing is based on the humidity of this uh, material you are using, we are based on the humidity, this sensing material responds in that way. Okay, so if you are applying some voltage across this, the current will change based on the humidity. Okay, so this is one thing. Basically in this one, in 2D, from 2D materials family, we can use graphene. Now we can see this NPK sensor. So this is also, you can see here, there are different types of sensors like conductivity based sensors, and they are commercially available, and electrochemical sensors, spectroscopy based sensors, ion selective electrodes, and optical sensors. So there are variety of uh, types of sensors which can be used for monitoring nitrogen, phosphorus, and potassium in the soil. And the cost reduction is basically, if you purchase these sensors, NPK sensor, the cost is around 6,000. Okay, more than 6,000 or above. Okay, so this, in this area, the challenge is how we can reduce the cost of these sensors. So for that, new materials are needed, which can be cheaper. Uh, so basically, if you want cheaper material, 2D materials can help us here, like graphene, reduced graphene oxide, molybdenum disulfide, vanadium sulfide. These materials can help us to make the conductivity based sensors for NPK monitoring. Okay. The typical procedure, if the figure 1 shows the schematic of that, you can see here, this is basically 2 electrode system, and in middle of that you are uh, uh, keeping graphene on top of it. Okay. So based on NPK value or NPK concentration in soil, it responds. Okay, detailed things we can discuss if you need, and then we can see how one can make this device. So like you take a substrate, then do some masking, and then thin film deposition you can do, and then shadow masking and metallization process. Okay, so in this way one can fabricate these sensors. Okay, so here again you can see the 2D materials as application. Okay, so we have seen that this in last 2-3 slides, that how this material system on can work for the can help us in agricultural applications. So now we can come to development part of these materials, how one can develop these materials. So first example we can see here, the growth process for monolayer tungsten diselenide. Okay, this is one 2D materials, and typically for this growth, my group use CBD system, and this is 2 furnace system. You can see here in schematic the furnace 1 and 2. It is shown in schematic. So for growth purpose, what we do basically, we take tungsten trioxide in one boat, and on top of that we keep silicon oxide material, and then in another boat we keep selenium, and argon and hydrogen is used as carrier gas for this. And at suitable temperature, if you heat furnace 1 and 2, this selenium and WO3 vaporize, and they react at the silicon oxide surface, and the tungsten selenide material is formed. Okay, and whatever the exhaust is there, that is come out from that side. Okay, so this is basically a quartz tube system. So to achieve the desired properties, there are various parameters which can be varied, like precursor amount, how much amount you are keeping sulfur and WO3, that will decide the grown WSC2 material, okay, quality. And the growth temperature, pressure during growth, distance between precursors, and substrate position on the board, flow rate of carrier gases, So all these are the parameters which you have flexibility to tune to achieve your desired properties for any desired application. Okay. So we can see here in similar way, one can do growth of any sulfide or selenide material. Okay. Now, few results which we can see here, like my group did this temperature variation of WO3 with average crystal size. So we found that it increases with temperature. Then selenium temperature, we varied after this varying WO3 temperature. We have seen that increment in crystals, and then it reduces. And similarly, hydrogen and argon gas flow was varied. So finally, we got some material which are single crystal in nature, and that is triangular in shape as shown in figure D and figure E. So you can see very light color things is present here on top of this substrate. Okay, so this is basically material which we get after growing this, after performing this growth. Okay. Now, sometimes we need actually good conductivity of a material for its application. So for that purpose, we did actually doping of this material. So for doping, it is very simple. Whatever setup you have, you keep the dopant related material to in another boat near the any one of both for which is suitable. For this one, the niobium oxide powder was suitable material to dope this material with niobium, and we kept this near to WA3 weight. So whatever you have seen in previous this setup, there is only one change. Here we are keeping a different material, furnace one. Okay. Now, how to confirm that this doping is done or not? Okay, in a material system. So for that, actually, you have to do some process that is called X-ray photoelectron spectroscopy to check whether this material is actually present in the lattice or not. Okay, in WO3, WS3, SE2 lattice or not. Okay, so we found that this material is present. We found peaks related to that. So this indicates that the doping is done. Another way to confirm is this, to do vary the to make two contacts and check the current voltage relation. Okay, so if the current is increasing, this means the conductivity has changed. It confirms the doping. Okay, so you can see here this separation, actually whatever we are taking, we varied this and we found that if the separation is 1 inch, we are getting good conductivity. Okay. So in this way, one can confirm the doping part. So why doping was needed? To tune the conductivity according to required application for the required application of this material for a device. Okay. Similarly, there are other things also like measurements like photoluminescence and Raman spectroscopy. That things also we checked actually, and we did a mapping of that. So you can see here, basically this tells us very uniform color. Uniform color means this is a high quality material after growth. This is photoluminescence map. You can see after that, you can see in this graph, the intensity of PL intensity is uniform near the edge we check actually for a surface. And this indicates that the grown material is a high quality material. Okay. Now, another, we fabricated a field effect transistor with these materials and with different channel length. And we found that for undoped WSC2 and niobium doped WSC2, if you check their Undoped one has amphoteric nature, means it works like sometimes as p type or n type. It has both ambipolar nature. Okay, sorry, ambipolar nature, not amphoteric. And the doped one has p type nature. Okay, if your gate voltage versus drain current graph, so high current in a negative bias, this means this type, this is showing p type conductivity. Okay, so this is basically a p channel FET. So from ambipolar FET to p channel FET we are able to make by niobium doping. Okay, similarly there is a way to calculate the seed carrier density and all, and that is done here also, and we found that if you gate voltage increases in negative side, the holes per unit area increases, especially because the electric field is more at the gate, so this material is very thin, so you will get higher hole in the layer. Okay, another material from this family is black phosphorus. So this material is needs actually high temperature and high growth, high temperature and high pressure condition. So whatever 3D materials you see like silicon or any other, even in 2D materials, uh, the condition is high temperature, low pressure. Okay, whatever systems we have, you may have heard about sputtering and MB and all. There are many type of machines to grow material. Okay, metal evaporator. So all these machines needs the growth needs high temperature, low pressure condition. But this materials needs high temperature and high pressure condition. So at high pressure, our these systems cannot operate whatever we have. So there is a special way to grow this. This is called chemical vapor transport technique. So that we have used, and this materials actually basically requires this condition, and we are we deposited this. We are able to grow this materials. That is called black phosphorus. Okay, so crystals look like this. Okay, and after growing this bulk material, if you want to make some device out of it, you have to transfer from this material to some other place. Okay, where you are preparing device. So therefore that a process is used called mechanical exfoliation that we did actually. Now it is found that this material is very unstable. Okay, so to stabilize this material, because it reacts with atmospheric humidity very rapidly, it makes OH bond very rapidly. So therefore this material is not very stable in atmosphere, but this material has potential applications in energy harvesting. Okay, like solar cells. So therefore, how to stabilize material, that study we did, and here we used silicon nitride and aluminum oxide passivation. We grow a different layer on top of it, very thin in nature. Okay, to make this material stable. Okay, so for that another process is used called atomic layer deposition. So we got very interesting thing that if you passivate this material, you put another layer of silicon nitride on top of this, what happens? This materials become very stable up to 550 degrees centigrade. So any device, high temperature device also you can fabricate using this material. Okay, so you can see here all the Raman related peaks, Raman are present up to 550 degrees centigrade. Okay, so this was the beauty of this passivation technique. Okay, about the thickness of this material, that another technique is called atomic force microscopy, that is done here. Okay, similarly aluminum oxide passivation was also used to stabilize this material, and up to 450 we got Raman peaks. Now both type of passivation we have compared. Okay, to check which one is best. So one way is we got that the silicon nitride passivation gives us high temperature stability in comparison to aluminum oxide passivation. Okay. Another thing is we have seen that if you do low temperature annealing of these materials, so you will get tensile stress. But if you do high temperature annealing, it restores its properties. Okay, so you can see here, these are the dashed lines in these figures. This is the actually peak position for the bulk material. Okay, but when you passivate this material with some other material you are keeping on top of it, the film is under stress. Okay, so to release that stress, you need high temperature annealing in both cases. So this is same thing is kept for compression. Okay, so we have seen that for silicon nitride passivation up to 550 degrees centigrade, this film is stable, and up to by aluminum oxide passivation up to 450 degrees centigrade, this is stable. So obviously the silicon nitride passivation is better for fabricating high temperature devices using phosphorus. Okay, black phosphorus. So our group fabricated a simple device that is called PN junction diode for this one, and the black phosphorus works as p-type layer of that junction, PN junction, and aluminum oxide is used as the n-type layer. Okay, and this whole thing is kept above silicon oxide. Okay, you can see silicon oxide substrate was there, and top of that it is fabricated. Okay, so using some fabrication technique that is called lithography, entered 2 electrodes, and we measured the current voltage characteristics at different temperatures. Okay, so we can see here as temperature increases, the current increases. Okay, and we can see here in, if you see this side at negative voltage, at higher temperature we are getting little bit higher leakage. Okay, so to confirm the quality of this fabricated diode, ideality factor is calculated for a diode. To check a quality of a diode, we always there is a parameter to indicate the quality of diode, that is ideality factor. Okay, so that we have calculated, and we found that if the temperature is increasing, the diode ideality factor also increases. Okay, so here we can see here for this one it is around silicon nitride passivation, it was around 3, and for typical silicon diode we have ideality factor around in range of 1 to 2. Okay, so it has that much quality like silicon diode. Okay, here, and but it can operate up to 500 degrees centigrade, this diode. So this was about a few growth techniques which we use to fabricate 2D materials, and we have seen that how these materials can be suitable for different sensor fabrications. Okay, and we have seen that how using a CBD system we can perform these growth, and we have seen a P-channel WSC2 FET, how we fabricated that, and growth of black phosphorus material. Okay, and passivation techniques also we have seen how to stabilize a material if it is unstable in atmosphere. Okay, now what are the opportunity in this area? So first thing is fabrication of different type of sensors for agriculture. Okay, that one can do using these materials. Okay, as we discussed, these materials has high surface area, so they can give you very high performance. Okay, in comparison to conventional materials. And another area is even in growth itself, these materials, you may have seen in my slide that the material is growing in some portion of the substrate and remaining portion there is nothing. Okay, so what is requirement for industry? It needs growth on a wafer scale. Suppose if a silicon wafer, so on whole area should be covered by this material. So that is not done. Okay, for few materials it is done, but for remaining one, we have to do. So wafer scale growth can be one area to work in this field. Okay. Another thing is few of these family members are unstable in atmosphere, so one can work on the stability part. Okay, different passivating materials one can check whether it is suitable or not, because if you vary the passivating material, the film under it, below it is under stress. Okay, so which one is suitable, one have to identify. So one area can be the stabilizing the 2D materials film using passivation techniques. And then fabrication of different devices, as we discussed, agriculture. There are other applications also, like photonics. People are working in this one, okay, and this spintronics, all these fancy thing people are doing this using these materials. Yeah, this for memory devices also people are using these materials, because you may have heard about short channel effect in MOSFET. Okay, so short channel effect is more in 3D materials, but if you use 2D materials, their layer thickness is very less. So short channel effect is less even if the device dimension is shrink to 4 to 5 nanometers even then. Okay, so short channel effects are less if you fabricate a MOS using this device. Okay, so this means you can fabricate MOS with very less dimension using this material, and in this way you can increase the number of device density on a chip. Okay, so in this way they are suitable for memory devices application also. Okay, so and then the integration part, one can, if one want, one can work on this integration of 2D material based devices. Okay, for a specific application. So these are the few areas where one can explore this material. Okay, so I am stopping here. Thank you all. So any question, please let me know.
Thank you, sir, for an enlightening and informative session. Now the floor is open for question answers. Participants could please communicate with the help of volunteers.
Any question? Please raise your hand.
Excellent talk, Sushil.
Thank you, sir.
One thing, like based on your expertise,
Yes, sir.
you know, TMDs can be grown based on sulfur, based on selenium, based
Yes,
on
sir.
many other things.
Yes, sir.
So which one you think should be, or one should be going for atomic scale semiconductor if it has to be coupled for agricultural sensor purpose?
I think, sir, sulfur will be more suitable in comparison to selenium, because finally, if we want to commercialize this material for sensor application, we need wafer scale growth. So using sulfur, growing this material in large area is easier in comparison to selenium based materials, because our experience is that if you use selenium, it's not very reactive during growth, and the grown material crystal size and that is small. It's not, I think it's very difficult to achieve wafer scale growth. So I think sulfur based material will be suitable.
Thank you, Sushil. One more question, may I ask?
Yes, yes.
Yeah, when you mentioned crystallite size,
Yes, sir.
is it absolutely necessary to have always monolayer? Because when people say wafer scale, they
Yes.
want to go for millimeter scale, centimeter scale even.
Yes, sir.
But via CVD, it may be like you know it better. It is very difficult to control
Yes,
if you
sir.
want to have centimeter scale of
Yes, sir.
TMDs.
Yes, sir. Yes.
So, but for applications, is it absolutely necessary that we should have, you know, enormous capability to control number of layers, or it does not matter?
Sir, for sensor application, it matters very less. But for if you are using this material for MOS application, then the thickness matters, because there, if you are, if you want to reduce the short channel effects, then a ultra thin body is needed, monolayer. So their uniform thickness we need on the wafer. But for sensor application, I think if it is multi-layer also, it's good, no issue. I think yes.
Any more questions?
Hello.
Yes,
To measure humidity, we need sensor on the surface, or we uh, take our sensor inside the soil.
inside the soil.
Okay, sir.
Yes,
So what is the
because if you are monitoring soil humidity, you need some sensor to go inside. Yeah. That also we actually use measure the soil. So there are two techniques. One is you are taking soil in a lab and measuring there. Another thing is you are putting sensor in field itself. Okay. So whatever sensors now available, they are they have 3 electrode system and they are used to put in the field itself. Okay, soil. Uh, so for that purpose, so there are two techniques as I told you. The 2D materials will support this which we can use directly in the field. Okay. So there the cost is challenge as I told you, because basically we use metal based sensor. So here if we apply the 2D materials somehow, they will be cheaper and we can use them for this NPK monitoring. Reuse, you can reuse them because what is happening, this material is not coming in contact of soil. There are electrodes which are very robust kind of things and they are coming in contact to the soil. So this is taking indirect signal, you can say. Okay, first your soil is coming in contact to the electrodes, and we can use some material which can which can be used which can actually give us long life for the sensor, and then whatever signal it is getting from there, it is reaching to the 2D materials. So your material, these soft materials are not coming in contact to the soil directly. That also can be measured, yeah, but for different monitoring different elements, you need different types of materials, because different materials has uh, different sensitivity for a particular element. Okay, yes. So these materials you can see here, there are a variety of family. So based on, you have to first do some suitability study which one will be suitable for a particular elements or monitor, and then one can decide. Yeah.
Okay,
Yes.
thank you, sir.
Yes. Yes.
Hello. Yes, sir. Thanks for the great talk. I was having a question regarding the passivation.
Yes.
Okay, as we know, the most heating element in a motherboard is the CPU.
Hmm.
So, are there any methods means used or tested using this technique to enhance the performance of the CPU as it gets heated the most?
So for that, actually, the passivation, whatever we discussed here, that was for stabilizing a material. Okay. But your question belong to thermoelectric effect of a material. Means whether there can be a good heat sink which can absorb heat uh, rapidly. So yeah, so as we can see here in this one, close this. I can tell. So in this family, 2D materials family, there are some specific members which can be used for this heat sink application. Like one example is vanadium disulfide. So it is found that vanadium disulfide has good thermoelectric properties and it has high thermal conductivity, and we can use for this one for heat sink. And any material which is vanadium based, it is suitable for heat sink application.
On top of that, can we use this black phosphorus layer or like the passivation to enhance it further? For
Black
this?
phosphorus itself can be used as a P-type MOS.
Yeah, that's.
And one important thing is for black phosphorus is it gives us very high hole mobility. Okay, because we can see any devices, always the electron mobility is high and hole mobility is low. Okay, so this material, this black phosphorus, it can give you very high hole mobility, minimum 1000 centimeters per volt. Okay, and it can vary up to I think 10,000 something at low temperature. So therefore, high hole, wherever you need application for P channel MOSFET, where high mobility is needed, black phosphorus can be a good candidate. Okay.
Sir.
Yes.
Thank you, sir, for your enlightened session. We are grateful to you for the time and efforts you took to share your experience with our IEEE community. Now I would like to request, sir, please. Now I would like to request our Professor Saibal Mukherjee to present an honor to the speaker, Dr. Sushil Kumar Pandey. Sir, please. Thank you, Professor Pandey. Thank you, Professor Mukherjee. Now I would request the participants to please assemble near the entrance of Sandipani Hall for the photo session. Due to the time constraint, I would request to hurry up the process. Please, everyone join. Volunteers would help you. ये माइक नीचे रखो, किसी का काम छोटी है। Settle down soon. We have to start the session. Welcome back, everyone. I would request everyone to keep their phones on silent mode. Next, I would like to invite Dr. Vivek Garg, Assistant Professor, SVNIT Surat, to deliver a session. Dr. Vivek Garg is a Assistant Professor from SVNIT Surat. Dr. Vivek Garg is an Assistant Professor at Sardar Vallabhbhai Institute, NIT Surat. He is currently working in the Department of Electronics Engineering at Sardar Vallabhbhai National Institute of Technology, Surat. Previously, he was an assistant professor in the Electronics Engineering Department at the Defense Institute of Advanced Technology, Pune, India. He received his PhD in Electrical Engineering from the Indian Institute of Technology, Indore, India. Since his PhD, he has been involved in a broad area of research in energy harvesting, photodetection, quantum technology, and defense applications. He has over 75 research publications, including journals, book chapters, and conferences. I would request Sir to please hand over the session. Sir, please. पॉइंटर वहाँ नीचे है के पास है पॉइंटर तो वो हो ना बोलना तो सिर्फ आई चेंज होगा
चलेगा क्लासरूम छोटा बिना माइक के
Okay. Good morning, everyone. I hope I am audible at the last, right? Closing of mic. It's all So, in the last session, the thing which is discussed basically the first part of your IoT network, that is sensors. So sensors by which you are collecting the data, and based on that you are processing those things, sending to internet, then further processes are done, whatever is required based on the data analyzed, right? So in this session, we are going to see mainly self-powered IoT infrastructure for sustainable energy management. So as number of nodes are increasing, number of sensors are increasing, right? So there is a need of power, right? Continuously you have to give power to eventually get the data to run the sensors, right? So there is a continuous requirement of giving the power. Right now, most of the things in basically power delivering section, we are using batteries, right? So batteries is not a proper solution. You can say you have to continuously recharge or you have to replace, right? And there is waste associated with the batteries also there, right? So there are different new technologies where we are thinking about how to give the power to these devices without need of these recharging or some waste from those devices, right? So for that purpose, there are different technologies there. Among them, we are going to see basically photovoltaic devices, basically which are harvesting energy from the indoor light sources. Indoor light source means most of the IoT networks devices which you are using, let's say 60 to 70% are inside the ambient, right? Aap room ke andar use kar rahe, you are using inside the room, correct? There are sensors which you are using for biomedicals, so those are viewed by particular persons. So all those sensors should be powered. So most of these energy can be collected by these power harvesters, basically photovoltaic devices, which will utilize these indoor light sources which are present everywhere. So in the indoor light sources, you have seen LEDs, CFLs, all those energies which is present inside the any room that can be utilized to harness, and eventually they will power those sensors, right? So this is a somewhat plan of this talk. We are going to discuss other aspects also. What are the typical technologies people are using for this purpose, and what are the challenges there, and how we can further improve these technologies to cater the need, whatever is required to power these sensors, right? So this is about my group at SVNIT. We are working on these three basic aspects: photovoltaics, which includes indoor as well as terrestrial and space PV applications. And if we consider energy storage devices, there are two aspects we are working on: photoelectrochemical cells and supercapacitors. And in quantum technology aspects, we are working on diamond-based NV centers for somewhat magnetic applications. So we are developing those aspects also. So these are the areas which we are working on. And currently we have 4 PhD, 4 BTech and 12 members in our group. So this is a plan. So introduction to IoT ecosystem. we'll see first typical what are the components present in IoT system, then their power management strategies, which is currently utilized. So what people are doing, they are somewhat managing in a way, let's say sensor will give you a data for a particular time duration, and then it will be off for, let's say, half an hour, then you are again collecting the data. So in that way, we are managing the power, right? You can enhance the life of your battery. So these are some management strategies by which people are working or improving these battery related requirements. So we'll see some energy harvesting strategies basically. So there are different sources of these renewable sources. It can be based on vibrations, heats, or radiations, which are solar radiations or indoor light radiations, right? So based on that, these harvesting strategies we'll discuss. Then different current technologies or their potential, means currently there are certain materials which are used for indoor harvesting as well as outdoor solar cell based devices. So their potential means maximum efficiency, what we achieved till now, how much power can be delivered using those devices. Then we'll see indoor based photovoltaic devices, what are the current technologies and what are the issues present in these technologies by which we can improve the energy requirement related aspects for IoT applications. Then slightly detailed discussion about indoor photovoltaics will be there. Then there is different constraints in indoor conditions compared to the outdoor. Indoor, you can see the light which you are receiving from LEDs, they are not distributed everywhere uniformly. So based on location of your sensors, the power delivered through LEDs are different. So that we have to consider, and based on that, certain managements are required. So all those aspects we are going to discuss. Then we'll see some particular applications, means we have designed devices. Now, how we can implement these devices in real-time scenarios. Let's say biomedical applications, you have to wear different belts, sensors, which can be placed with the body of particular human. So what are the options? How you can include these IPV devices to power them? It can be in terms of clothes. So there will be clothes based on these IPV devices. Some threads will be made based on these coatings, and that will act as energy harvested inside environment. So all those aspects we are going to discuss in this session. And finally, there are certain limitations in this system because there is no standard till now available worldwide for indoor applications. So that is a need, and some other aspects related to that we are going to discuss. So this, everyone aware of Internet of Things. This is a topic. In this, basically, you can see there are large applications already available in different areas. You can see IoT-enabled mobile devices we are using, IoT-enabled shops, airports, factories. There are different aspects where IoT-enabled devices are present, right? Now, if you see, nowadays, these things are increasing in a large way. So as number of sensors are increasing, there is a need of more number of batteries are required, because most of these sensors are now powered using the batteries. And if you consider in general case, the lifetime of your sensors which is developed, that is relatively very large compared to the batteries. Means your particular sensor should be recharged many times. It will not give service to whole his lifetime, right? So sensor life is pretty large compared to the traditional battery sources which we are using. So our basic aim is somewhat we have to improve our battery in a way so that it can supply power to that sensor for its particular lifetime. Aapko ek sensor, your particular sensor should not need a change in the power requirements. There should be no requirement of additional battery or recharging. So that is a main focus by which we can achieve all these aspects, right? So in particular IoT network, you have seen maybe distributed sensor nodes, remote sensor nodes, both are possible. Then actuators to perform a particular action. Then communication devices which communicate with different networks. It will send to the common particular network, and after that everything will be processed, right? Now if we see the market trend, so the cost of these portable devices or the sensors is reducing basically from 1980s to 2020. You can see the cost is reducing. It is almost $1 now. So with increase, basically reduction in the particular cost is also there with reduction in the size. When you miniaturize your device, the power requirements also reduce. And eventually, if your power requirements are less, then indoor photovoltaics can cater those requirements. Because in indoor photovoltaics, power generation is relatively less because the light you receive from the LED sources are relatively very less compared to the solar. If you quantify this, so the outside radiation is almost 1,000 times compared to traditional LED, which is working at 1,000 lux, right? So for 1,000 lux LED, the light intensity which you are getting inside, that is 1,000 times less than the outdoor sun intensity. So that's why overall power which you can extract from any indoor photovoltaics, that is relatively less. That's why this IoT related applications are IoT related basically applications of indoor photovoltaics is recently started. Now people are exploring these indoor photovoltaic devices because now photovoltaic devices, whatever power they are giving, that is enough to power these sensors, right? So now people are exploring these aspects. If you quantify, there are different power requirements. So standby mode in laptop, real-time clock, calculator, these are typical power requirements you can see. This much power is required. And typically, the power which you can extract from an indoor photovoltaic device with 1 cross 1 centimeter area, that is around few microwatts. So there is a huge scope of improvement because till now, whatever the devices are available, they are having efficiency around 30%, that is maximum in indoor conditions. And theoretical limit for those cases is around 60%. So we are at the half of the potential application, potential energy, basically we can say efficiency which can extract. Okay? So in that case, what we are seeing, we have at least 50% scope of improvement in current best devices, but there are some issues in the current best devices also. Let's say most of the devices which is fabricated in indoor environment, 30% case if we consider, that is based on perovskite, that is lead based perovskites. So lead is toxic and in indoor environments you can think, because people are more interacting with these sensors, right? If you are using any sensor in powering a particular, say, fitness monitor, so if it is directly in contact with the person, so that will be more severe in case of indoor conditions. In traditional outdoor devices also, we are trying to remove lead, any toxic element which is present. So all those things those issues will be more severe in case of indoor environments. So that's why we have to think about some alternate materials which should not contain any toxic material, which will harmful to the people, right? So all these things should be considered. Based on that, some new innovations are required, and those things people are doing nowadays. So those things we are going to see one by one. Yes, so in terms of power management strategies, what people are using, let's say in the first case, top one, some energy saving aspects means you put your devices in standby mode, deep sleep mode for a particular time duration. Whenever, let's say, particular sensing parameter you need for half an hour, or after 1 hour you need, that parameter will not change in a small time duration. So in that way, people are doing somewhat power management. In other than that, people are also utilizing AI ML models so that they properly predict what should be the energy requirement for your sensor, what is the power available inside. Let's say if you are using indoor environments, so how much light is available at a particular time duration. All those things can be trained. That can be, data can be extracted, and based on that, these prediction can be done. These are the basic strategies which people are using nowadays mostly. And based on the current scenarios, the battery is a main source which is delivering the power. So if you consider the batteries, their lifetime is very less compared to the lifetime of your sensors, as well as there is a waste associated with these batteries. So this has to be removed from these systems. So for that purpose, there are different renewable energy options available. So among them, it can be based on ambient heats, it can be based on vibration sensors, means thermoelectric. There are different aspects available. Among them, one of the major aspects which we are going to discuss in this session, that is about the harvesting the light, which is present outside, means sunlight, as well as inside, which is because of these LED lights which you are using in the inside environment. So all in this session, mainly we'll think about these indoor-based light sources and their application for harvesting the energy and powering the sensors for these IoT applications. So regarding the battery, the traditional thing, whatever the material you are using for powering the device, eventually what you want, whatever the material you have used, there should be a proper disposing aspect should be there. There should be proper guideline if their lifetime is less, but eventually what you want, their lifetime should be more, right? Or whatever material is there, that should be, or the battery should be rechargeable. But even after that also, the battery lifetime, material which are used for batteries fabrication, those are having some issues, eventually issues related to disposing these materials is present. And till now, even in India, there is no proper guideline for disposing these batteries. We have seen everywhere there are various batteries used for household UPS we are using, inverters we are using, but there is no proper guideline, right? So there are some issues. So that's why people are thinking about removing those batteries and replacing these batteries with some renewable source of energy. And that energy should be harvested by a device. So one of the very high potential device that we are discussing here is indoor light harvesting. So these are the power requirements for typical IoT components. You can see RFID that needs around 10 microwatt, LoRa, passive Wi-Fi, BLE, ANT. So these are different options. And you can see the power requirements there, right? So if you consider particular solar cell, 10 centimeter square IPV cell, if their efficiency is 30% and 8-hour indoor light is available with white light, this much power intensity, then you can achieve or you can power these devices which are below this line, means RFID, LoRa, that can be powered with these indoor devices, right? So these are the basic assessment based on the efficiencies. Let's say that's why we are seeing there is a scope. If efficiency is still now 30 and it can be reached, the maximum value around that is 60%. So if you are able to achieve, then half of the area requirement will be there. The smaller area requirement will be there, power requirement will be relatively less. So there are various factors which can be improved and energy can be delivered properly to the sensors. So these are some motivations, and eventually there are certain materials which are mentioned here, right? Upper one is this one, 24-hour indoor lighting conditions. So there are different aspects just summarized here. We are going to discuss each one by one in the coming slides. Okay, so in terms of energy harvesting, there are different aspects related to renewable aspects that is based on thermoelectric, which utilizes ambient heat. Similarly, radio frequency, RF frequency available, some particular transmitters will be there. Based on that, you can transmit the energy and utilize for powering the devices. Then piezoelectric materials, triboelectric. Among them, we are going to discuss mainly these photovoltaic aspects. In that photovoltaic particular one stream we are going to discuss in this session, that is based on indoor photovoltaics. So considering these devices, eventually you have to create a particular assembly which can give you the energy harvester. So this section of this particular setup, we are going to discuss that energy harvester, how it will provide the energy for remaining components present in your particular IoT node. Okay. So for different energy harvesters are the options available right now. So EM wave, RF, thermoelectric generator, then PV for indoor conditions, PV for outdoor, then mechanical energy harvesting. There are different energy harvesting aspects which are utilized till now. And we are mainly focusing on these two aspects, PV. So indoor and this outdoor cases. So the outdoor cases, you can achieve a power of 10 to the power 4. And in terms of this indoor case, that is a particular range of 10 to the power 2. So that there is a scope for the improvement, and that can be assessed in this session. So this is a particular node which utilizes outdoor particular solar cell. So which contains these components, and these particular solar powers can be used for powering a particular sensors. Let's say for tank water monitoring, there are say NPK sensors powering these sensors. All those things can be done using these photovoltaic devices. So this is a particular scenario in the case of outdoor photovoltaic devices, but we are mainly concerned about in this session indoor photovoltaic devices. So in the traditional outdoor photovoltaic devices, the material requirement is totally different. The reason for that is, you can see in this plot, the outdoor spectrum or the solar spectrum which received at the Earth's surface is this gray one. And this intensity is basically widespread up to 2000 nanometers. So that is shown up to 1100 nanometers, right? So if you want to basically utilize this energy, your band gap should be at this edge, right? If energy is higher than this edge, these particular energy will be absorbed by that material. So accordingly, if you consider for indoor light sources here, white LED, CFL and halogen spectrum is present. Based on spectrum, you can identify if I choose a material around 700 nanometers, means the band gap corresponding, then you are able to absorb all this energy which is higher than that. So no need to select a material which is having a lower band gap. Issue of that is, if your band gap is very less, the excess energy which is absorbed by the material, that will be lost in terms of heat. So that to address that, and that particular term in solar community, we call it as thermalization losses. Means if your band gap is small, whatever the excess energy is there, so there is a large amount of excess energy that will be lost in terms of heat. To tackle that, you have to select a particular material which is having band gap corresponding to this wavelength around 700. This comes around 2 electron volts. And traditional solar cell, if you see, so the peak is around 500 nanometers. So the band gap requirement for the material for outdoor energy harvesting, that should be around 1.3 electron volts. So there is a very big change in terms of material itself. So you cannot utilize traditional outdoor solar cells or the materials which is used to harvest outdoor lights. You need a specific material where the band gap requirement is totally different, right? So in indoor cases, the band gap requirement is around 1.9. In outdoor cases, the band gap requirement is 1.3. So there is another aspect. So based on this, we have assessed the band gap requirement for a particular material in indoor conditions, right? Now the second aspect is we are using different lights in different environments, right? In small households, this case, this is the luminance or power density which you are achieved in the particular this much luminescence area. So up to below 200, that can be used in this area, warehouse, corridors, dining area. In typical office areas, this range of light illuminance is around 400 lux. Then further for different regions or different spaces, the intensity of the light or LEDs which we are using, that is different, right? So you can expect for the larger, let's say malls where the light intensity is relatively larger. So you can get a better, you can get better current or eventually efficiency from the device, right? More power is available, you can utilize in a better way in those areas. But that's why you can see in outdoor cases, the input spectra or the solar spectra is constant. Wherever you will utilize those devices, the overall output will be similar. But for indoor cases in different scenarios where you are using, because device performance will depend on humidity also, temperature also, at what temperature you are operating your devices. So there are different factors, right? So in different regions, different office spaces or household, there is a different power extraction from your device or energy extraction from your device. So in indoor cases, there are multiple variables available. You have to properly tune your device. And as I already told, for indoor, there is no proper guidelines available worldwide also. There is no particular measurement criteria like what are standard test condition for indoor solar cells, what should be the typical indoor light source, what should be the power density of that, because different company light source, if you see LEDs, their power output will be different, right? So there are no proper guidelines or proper standards defined for indoor solar cells till now. So there are multiple variables available, and people are working on to standardize these characterization aspects in indoor solar cells also. So these are the different conditions, scenarios where the different light intensities are available.
Sir, we
Now-
have 5 more minutes.
Sorry?
So you have 5 minutes.
Okay.
So we
Good.
have to-
So indoor light spectra. So based on the indoor light spectra, so the band gap, whatever the band gap we have assessed, that is around 2 electron volts at this particular electron volt band gap, or the band gap of the material, if it lies in this region, your efficiency can be around 0.6, means 60% you can achieve with these particular light sources. Now these are the market scenarios for IPV market size versus wireless sensor nodes. So wireless sensor nodes, you can see from 2017, it is increased by a large amount. So similarly, IPV markets is also currently increasing. Yeah? Similar manner. And in terms of the production, so cost, so eventually IPV is continuously increasing from 2016 to 2023. So these are some of the materials and their best efficiency reported till now. So monocrystalline solar cells, you can see the difference. In traditional solar cells, 26% efficiency under one sun, that is outdoor spectra. In indoor spectra, that is 6%. The reason is the band gap. Band gap is not proper, that's why your efficiency is less in this case. So there are other materials also. So perovskite is one of the champion materials in this, which is having efficiency of 40%. So this is the best till now. But issue with the perovskite is it contains lead, and that is very much severe when you are utilizing it in indoor environment. So lead is directly in contact with the people. So that should be avoided basically. Then there are different materials which people have explored, which have the potential to achieve this much efficiency. So people are exploring some other materials which do not contain lead. So in these materials, you can see most of the materials does not contain any lead components. So this can be used in indoor environments. There will be no concern about the safety and all those aspects or the health concerns. So in terms of design, perovskite, there are possibility of flexible device design. There is a integrated circuit design or the devices design using these cells. And as I told you, in the indoor environments, the light intensity is different in different regions. So this experiment is done for a particular whole year. And in that case, it is analyzed for different sensor is placed at a particular location and what intensity you are achieving inside the room, that is assessed. And you can see from different, say, month, the intensity is different. So it depends on the ambient conditions also. That is the issue with indoor. But you can see outdoor spectrum is more variable if you consider the whole year. In winters, there will be very less solar radiation, but here there will not be that much difference, but variation should be there in this case also. That is analyzed using this particular group. Then there is a variable application where here the battery store, these fiber-based batteries are, and this whole particular cloth is made up of IPB-based coatings. So this material-based coating is prepared, and this can be weared by a particular person, and this can be utilized to power the sensors which are, say, let's say in watch or any biomedical sensor if you are wearing it with your body, right? Those can be powered using these ways. So these are some of the ways by which you can utilize indoor devices for powering the IoT nodes, right? So if you see, as we discussed, the area requirement should be higher so that you can get enough power or you can extract energy. So that's why the area of your device should be relatively larger. So this is the one of the very simple way to achieve that. If you wear a cloth, that area can be slightly larger. So that is one of the best solutions people have proposed and they have implemented. So practically, you can find there are some options available in the market, also Amazon or somewhere in not in India. These coated materials or solar-based jackets are available, right? So for walkie-talkie charging and all those aspects, so I'll skip this. Then there is another application along with storing the energy which you are getting from LEDs that can be used for transmitting the data, means the communication can also be done. So that communication we generally called as a visible light communication or VLC. So in this you can integrate both. You can harvest the energy from the light as well as you can use that for the communicating or the communication purpose also. So this is an integration of two different applications, IPV as well as the visible light communication. Then there is another aspect of colored solar cells. This I'll skip because of time constraints. So in colored also the band gap requirement is high because you do not want to absorb visible light, correct? Then only it will be transparent. So because of that, the requirements will be different, and that is close to outdoor, basically indoor requirement. That's why you can harness indoor light, means diffuse light also using these colored solar cells. So these are part of building integrated photovoltaic devices. In that way, it is utilized, right? So this can also harness indoor energy. And this is the conclusion. So IPVs have tremendous potential to cater the need of the power for IoT, because till now the efficiency, whatever is achieved for the material, that is 40, but that material is having the toxicity issues and there are various other concerns also. So people are exploring new materials which don't have these components, and eventually these can be utilized. So these are the summary. Some issues are present related to standards and all, those are summarized here. So this is all about this. Thank you.
Thank you, sir. Any queries you can please ask. Volunteers, please help.
Ask about indoor PV.
Yes.
So it is in the research mode or it is in the production also, because that is some new thing and which is very much required also.
Yes.
Right now.
So it is in production also. For small sensors, people are using these also, but that is in very small scale till now. But I've shown in the chart that recent years that research in these domains are basically say exploded somewhat, you can say. There are large number of papers coming, people are working on that. But silicon-based indoor solar cells we have seen quite early. In calculators that is available. So indoor also it can harvest. So there are newer materials people are exploring, but silicon the crystalline silicon efficiency is around 6% only. So that is already available in your household uses, but there are newer materials, perovskite-based materials are also nowadays used, and some small sensors they are utilizing to power.
And again, the harm it will cause when we are using it in a wearable.
Yes.
Like, are the rays okay for human being? The research has been done, or
So
it is in the process?
Yes, rays in terms of these LEDs are already there. We are using these LEDs. We are surrounded by these LEDs. There should be no harm. That's why we are using in indoor conditions. So there is no such issue regarding this. But this health issues that is related to the component which I said element that is lead. So that people are trying to remove. Other in terms of light, there is no such issue. No concern is there. Yes.
Hello, sir. Thank you. Sir, can you elaborate on the lead poisoning issues that you were telling?
So in terms of lead, if you see the toxicity concerns in European domain, European region, that is totally banned. So CD, lead, if it is below 2% also, then that is not considerable. So it should be less than 1%. So that is very difficult for these devices. So that content is slightly larger. So there are certain guidelines already available worldwide. They tested and they set up rules that the lead content should be less than 1%. It should not be more than that. So that is somewhat you can think that way. Right?
So how come this is affecting us? Like how it is getting to us?
See, if you are in contact with any lead-based material, if you have touched that, lead can be in your hands, and eventually you can inhale. So based on that, it will in your respiratory system, and there will be certain issues because of those lead inside your body. So there are the other ways also by which lead can be inside your body. So there are many. So eventually what we want, there should be no interaction of human with these elements so that you can minimize these issues. And that's why when you are considering indoor devices, so eventually you will able to interact with these devices. Aap touch karoge, you are able to touch somewhat, you are placing sensor somewhere else. Then in that case, the possibility of contacting with those sensors is relatively higher. So in outdoor cases, the lead-based issues are slightly less in outdoor solar cells, but in indoor cases, it's possible you are interacting with these sensors, then the possibility of issues related to health will be more severe in that case. So that interaction should be minimized. That's why people are exploring other than lead-based materials for indoor applications. Outdoor, it is already used. That is standard material. Yes.
Thank you, sir, for the great
Sir,
explanation.
one more last question.
Yeah.
So, sir, my question was like you were showing that wearable, you can say kind of like solar panel only.
Yes.
Okay, power harvester.
Yes.
So means as it is having some electric current going through it, so then it would create some magnetic field and electric field around them. So
Yes.
won't that hamper the human body in any way?
Yes, so that's what in indoor cases, the current values, those values are very less till now in microamperes or that in that range. So till now, that is not a big concern, right? You are using handheld devices, watches, there are certain already radiations that is having larger power requirements, batteries are having more power. So if that is considerable, then you cannot think about issues related to indoor because their power generation, all those aspects are very less compared to these variable devices. So there is no such issue in terms of that.
Yes, sir.
Thank you, Dr. Vivek Garg, for an enlightening session. We are grateful to you for your time and efforts you took to join our IEEE community. Now I would request Professor Saibal Mukherjee to present an honor to our speaker, Dr. Vivek Garg. Sir, please. Thank you, Professor Mukherjee. Thank you, Dr. Garg. Now, after an enlightened talk from the academia experts, now we have a session from the industrial talk session. I would like to invite Dr. Rohit Singh Director Payam Nakshatra Agrotech Private Limited. Dr. Singh is a Dr. Singh is currently an assistant professor in the Department of Electrical Engineering at Shivnadar University, India. He is an electrical engineer by education and holds a PhD from the Indian Institute of Technology, Indore, India. He has done his MTech in Electronics and Communication Engineering with specialization in VLSI systems technology from Sivnadar University. He received a startup research grant from SERB DST in 2019. He also received the INSA Visiting Scientist Fellowship in 2021. His current research interests are in embedded system, the Internet of Things, and nanotechnology, nanoelectronics. He has also incorporated a startup along with his colleagues in agri-tech domain. The name of his startup is Payam Nakshatra Agrotech Private Limited. Sir, please. Mic is okay.
Thank you, Poonam, for such a nice introduction. And I would like to thank Sir for inviting me and giving this opportunity to discuss about my company in this platform. So I'm assistant professor in electrical department at Sivnadar University, Greater Noida, as well as I also opened a startup company there in 2022 on 12th June 2022 exactly. So the name of my company is Payam Nakshatra Agrotechnology. You can see the logo as well. So why I started in the agro tech domain. So basically, if you see the thrust of the government, whether it is government is looking on the agro technology or not. So the government is actually working in the digital agriculture mission, and our former honorable minister Narendra Singh Tomar, the agriculture minister and the former welfare minister, he replied in a written reply to the Lok Sabha in the Lok Sabha for a question that we are working in the digital agriculture. Okay, and what are the technology the government is focusing in this digital agriculture? So government is basically focusing the newer technology like which you are currently hearing most of the times. The buzzwords you can say that artificial intelligence, machine learning, blockchain, Internet of Things, robotics. Okay. And some of the target sectors like what government is focusing is that weather prediction, market size, and extreme weather alerts, input dealers. So these are some of the targets which are where government is looking, which directly benefit the farmers to enhance their income. Okay, and along with this, like on the field, the government is focusing on like field soil testing. So soil testing is very crucial issue for the farmers. The uh, in olden days the soil has to be taken to the laboratory for testing, but nowadays we have sensors which we can dip directly and it will give you the content of the soils. So if you know then what is the nutrients available in the soil, accordingly you will use the fertilizers. Otherwise, like farmers are basically putting the fertilizers just because their father said or their forefather said that you have to put 2 times fertilizers in the field and you have to irrigate 3 times, okay, without any scientific things. So slowly government is working on that, and government is launch many initiative and schemes where farmers can be benefited, and also government is trying to educate the farmers about these technologies. So like I, along with my 2 colleagues in the civil engineering departments, they are also basically working in the agriculture domains. So we thought that we will do something related to the agriculture. Okay, so we cannot focus all the aspect. So we focused on the soil testing as well as the soil moisture monitoring and the need of the water. Okay, so we'll go into the details slowly. So first I will give you some idea like where you can use the IoT in the agriculture domain. Okay, So if we see the role of IoT actually in the agriculture, it's not only the soil monitoring. Okay. So it starts with the farming first. In the farming fields, you have to like monitor the farms and monitor the crop health as well as the water requirements, and you have to apply some sensors for that. Then others is also like transportation. So during transportation, some of the crops required continuous monitoring. So there also you have to implant some sensors, and you have to monitor the data in that. Then storage. So in cold storage, like you have to continuously monitor the environment in the cold storage, like humidity, temperature. Okay. Then processing, logistics, retail markets. So anyway, after the farm, the last stage in the market where the farmers has to sell. So at every stage, if you do monitoring, you will save the product, because if we don't monitor continuously at every stage where there is some wastage in the product. Okay. So how you can make an IoT ecosystem. So if you see the broader way, the IoT system is looks like you have to install some sensor nodes in the field if you are monitoring the fields. Okay. Like the monitoring of the moistures, monitoring of the nutrients in the field, you have to install the different sensor nodes. What is sensor nodes exactly? I will discuss this in the next slide. And then once the sensors are giving the data, you have to process them at intermediate and upload the data to some cloud applications. Okay. Then only you can do some analysis on that cloud applications, and after that you can basically build some applications, user applications or user interface, you can say, like mobile applications or the web-based applications, where you can visualize the data as well as you can give the alerts to the farmers, and you can take some actions also, okay, from the user interface. So what are the technology in terms of, like, if you are engineers, what are the technology you need to know if you want to build some systems related to it? So first is we have to build the sensor node. Okay. So what is sensor node exactly? So sensor node basically comprises of the different sensors you require. So like if you are monitoring the soil, so you require one moisture sensor, which is very much needed. And then you require the temperature and humidity of the ambient also. Okay. As well as you require some NPK sensors for monitoring the nutrients, and you require the wind speed sensors, rain sensors, etc., so that you have a full knowledge of what's going on in the field. Okay. And then all these sensors like send the data either in the form of analog or in the form of digital. Okay. So these sensors cannot directly send the data to the cloud. So these sensors will send the data to microcontroller. So I hope all of you are aware about what is microcontrollers. Okay. So microcontrollers will receive all this data, and then microcontroller can process it their end, and after processing it has to store some end results. Okay. So to store some end results, it had to transfer the end results to some locations. So for transmitting, you require one transmitting module. You have to connect one transmitting module to the your microcontroller. Now what are the transmitting modules you have to connect? There are various transmitting modules available. You might have heard the name of Bluetooth. Bluetooth everyone knows, Wi-Fi everyone knows, but Wi-Fi and Bluetooth we try to avoid when we are using the sensor nodes in the field. The reason is that these Bluetooth and Wi-Fi, they consume a lot of power. Even though the power is in milliwatt, but since we are running on the battery, and as the Dr. Vivek said that the battery life is, if you continuously run the sensor node, like battery will be drained in 4 days, even if you use a hi-fi power banks. Okay. So you have to choose some microcontrollers and transmitting modules in such a way so that power consumption can be minimized. There are other ways also, but initially we can choose at the hardware level also. So there are various microcontrollers available. This picture is from the STM32 microcontroller family. This is basically designed by the ST Microelectronics company. I was in this company for 1 year before the PhD. So I was aware that this microcontroller was at the development stage at that time. But nowadays there are other companies also. And as a student, you might have heard the name of Arduino board. So Arduino we basically use for the hobby projects. But if you are going for actual industrial deployment, Arduino boards we don't use. We use basically the standards microcontroller boards. Okay. And then sensor transmitting modules. So since we cannot use the Wi-Fi, we cannot use the Bluetooth. So what are the other things? So we have to check the IEEE standard 802.15.4, which says that we require some low data transmitting, like low data rate Wi-Fi modules. Okay, because here we don't want high data rate. We are not going to stream the video or audio. Okay, we are going to transmit the sensor data which is in KB, even less than KB. So low data rate, if we use low data rate transmitting modules, the power consumption is obviously low. So what are the options? The Zigbee, we are probably using Zigbee, Sigfox, JetWave, LoRa. Okay, so there are every technology have their merits and demerits, and depending on applications, you have to select one. So the first criteria is, if you want, distance is the first criteria. Like if you want to transmit from this node to the, let's say your second node is sitting at 100 meters away. So for 100 meters, you can go with the Zigbee. Zigbee can transmit up to 100 and 200 meters, and it consumes power in milliwatt when it is actually transmitting. When it is ideal, it is consuming around 1 milliwatt. Okay. If you want further beyond that distance, then you have to go for the LoRa, which is long range. Okay. So LoRa with walls and all, it can transmit up to 1.8 kilometers. And if there is no walls hindrance, line of sight, it can go up to 10 kilometers. Okay. So all these technology I have tested, okay, in my lab. So we have made the communication systems from Zigbee as well as LoRa. Okay. And we have compared like how far they can transmit. And when you are using this technology, I also have to see the government regulations, because we, as a company, if you are using purely for the academic purpose, there is no trouble. But if you are testing anything on the name of company, we have to follow the government regulations also. So like LoRa, they can work on the different frequency bands, but there is only one frequency band which is freely available in the India. So we have to use that only. Okay. So whenever we are testing anything, you have to follow the government regulations, and then accordingly you have to select. So after so many iterations, we thought that we will use LoRa modules. What we can do, you can reduce the frequency, which is also permissible by the government. So distance will be reduced, but we are able to transmit when we want long distance, like 1 kilometers, 2 kilometers, which basically requires in the hilly areas or the train. Okay. So there you can increase the frequency. It also consumes very low power. Okay. So these are some of the like transmitting modules which we have to select. And nowadays some companies also starts making a microcontroller as well as the transmitting modules integrated in one chip. Okay. So that the power consumption is also minimized. Otherwise, in interfacing, we consume more power. Okay. Now, this is one application which we are targeting to build. Okay. So, like one sensor node. Now, sensor nodes in the previously you have seen like one transmitting module, it transmit the data to some locations. Now we have to make a coordinator node. Coordinator is basically what, let's say you have 100 sensor nodes. Now you cannot provide internet to all the 100 sensor nodes. It is difficult to provide internet to all the 100 sensor nodes in the field. Okay. So we can give one sensor node the internet access. Okay. By connecting either LAN, Wi-Fi, GSM, any technology, you can give internet to one sensor node, and then all the other sensor nodes will wirelessly send the data to this node. So we call it coordinator, and it will upload the data to cloud. Okay. After cloud, we can build some applications for end users, like web-based or the mobile applications. But from my personal experience, like I have seen that many farmers, they are still not using the smartphones. Okay. So if they are not using smartphones, then what is the solution? So we thought we'll go for the basic phone also. So in the basic phone, we can send the SMS, okay, SMS alerts to the farmers. So there are many websites which will provide you how to send the SMS. Okay, Toolio is one, and there are others also. So we integrated all the things on the cloud, and then the web application is still not fully built. Okay. So this looks like easy, but if you go for building, at every stage you have to learn so many things. Okay. If you want to send some data to the cloud, so anybody know what are the different types of cloud services available? Anyone did any survey? So if you want to upload some data on the cloud, there are basically 3 different types of cloud services available, like software as a service, platform as a service, and infrastructure as a service. Each different types of cloud services, depending on what you are using, the charges will be different. If you go software as a service cloud applications, so the cloud vendor company will build all the software part, and where you have to just upload your data and everything will be done by them, and they will build a nice widget and everything, you will see the data, but charges will be high. Okay, then the other is platform as a service. If they will give the platform as a service, then in the platform you have to build some instances. Instances means like you have to build a virtual computer, you have to select the RAM, ROM, hard, and the hard disk, processor unit, everything according to your. So those hardware will be allocated at some remote locations to you, and depending on what you are selecting, they will charge you. Okay, this is called the platform as a service. So I had some idea like on the platform as a service based. Okay, so I went for that so that I can manage all the things along with the operating system. Infrastructure service is the like where they will just give the infrastructure, everything you have to manage. So if everything you have to manage, then customer or the end user has to be technically sound in that. So as per your technical knowledge, you can choose whether you are going for software as a service, platform as a service, or infrastructure as a service. The fourth category is in-house or in-premise clouds services, which nowadays it is like not advisable unless until you are a very big. So immediately if you want to test something, you can go for software as a service. Okay, and there are many vendors. If you want to just try them, so you just have to register, sign up, and they will give you some few free credits. You can use that to learn that. Okay, after that you have to just remove your account or delink your credit card, because to register on them you require credit card. You have to give the credit card information. They will not charge anything, but if you keep using beyond the time period, they will charge. So you have to be keep this in mind. So big cloud services are like the Google Clouds is the big cloud services, and then AWS, Amazon. So Amazon, we are generally seeing as the retail market, like we purchase something from the Amazon, but you will be surprised that the huge revenue is coming from their AWS services by selling the cloud, not by selling these retail goods. Okay, then others are like DigitalOcean, Heroku, and there are many more cloud services, ThinkSpeak, ThinkSboard. Okay, so you can use anyone. Initially everyone gives some free credits so that you can explore, and then you can go for the which one you want. Okay? So this, like I discussed, like if you make a sensor node, how the sensor nodes will give the data to the coordinator. So this is just the diagram that if you have different sensor nodes, all the sensor nodes will send the data to the coordinator. Okay. Now, for a startup, like just listening the name, it seems fancy, but opening a startup is not an easy job. Okay, it's like it's not easy. It's like adventurous also, and difficult. Sometimes you will frustrate. You want that I will leave this and go something and do something else. But like I was interested to open a startup since my BTech. So after in doing MTech, I did internship in ST Microelectronics. After PhD, my thesis defense, after submission the thesis, one of my MTech faculty, he opened one startup company in Bangalore. So I contacted with him, and I went there for 9 months to learn how the startups actually work. Okay? So in a startup, like you are the one who has to do everything. Like if you are staying in a house, so झाड़ू पोछा बर्तन से लेकर के खाना बनाने, everything you have to do. Then only you can manage the startup. Okay, the journey is not easy. You will not get money in 1 year, 2 years. You have to wait till 4 or 5 years so that your startup matures and you start earning some revenue.
Sorry to interrupt, sir.
Yeah.
You have 10 minutes to
Okay,
wind
okay.
up.
I will
the
finish in
answer.
10 minutes.
Yes, sir. Thank you.
So you have to have a patience for the startup for that much time. Then only you can think, okay, you are a businessman. So what are the things you require for the startup? First is the idea you require. Okay. So I recommend that if your idea is unique, you first file a patent for your idea. The reason is that you are going to discuss your idea at different platforms, okay, in different public domains, okay, like idea challenge, hackathon. So your idea is exposed. After some days, like someone else will pick up your idea, then you cannot claim that this is my idea because it is not patented. So better you file one patent, or if you are designing some product, you file one design patent. You will get design patent in 6 months. The innovation patent will take time, but design patent you will get 6 months to 9 months. Okay? So at least file some design patent to secure your idea. Okay? That is very important. Then the next very important thing is you require a core members team. You cannot open a startup alone. If you want, then it's very difficult to drive that. So you require a core member team. Core member team should not leave the startup in middle. Okay, if one members go away, then your startup will like vanish. So you require a dedicated core members team to do that, to work on that. And then the third is the funding, because many persons have the huge amount of funding, okay, huge amounts of funds, but they don't have the startup company. Why? Because they don't have idea, or they don't have core members team. Some of the students, they have the idea, but they don't have core members team. If you ask them to do a group project, if it is a 4 members team, everyone will start fighting. I will do this part and that part. Okay. So you have a core members and everyone should be on same level, and you can discuss openly. There should not be hidden among your like business partner. So everything has to be open and crystal clear. Then only your partnership will run. Then funds. So there are many opportunities for the funds. And the college also nowadays mostly college have the incubation centers. So you can approach your incubation centers for initial seed funds. But one thing I would like to say, that no 100% funding will be there. You have to invest something from the pocket. The reason is that in 2017 or previous to that, the government used to give 100% funding to the startup companies. So in Bangalore, many companies were established, and once the funding finish, the company finish. Okay. So government will give you subsidy, will give you loans on the lower interest rate. Like you can get loans for 4%, 3.5% interest rate. Okay. They will give you subsidy in cloud subscriptions. They will give you subsidy in the like office space. So government also have the like incubation centers outside the university. You can approach there also. But some amount you have to invest from your pocket. The reason is, if you invest some amount from your pocket, you will take the responsibility. That money is going from your pocket. If money is going from someone else's pocket, who cares? So if you invest something from your pocket, then you will be serious about your startup and you will work hard to make the startup success. Okay. So for the startup, like since I am working in the university, so I have to take permissions from the university, and I have taken the permission from the university for opening the startup. And for that, they are giving the some access for the laboratories and some initial funding and office spaces. In respect of that, they are taking 4% share in the company. So what are the services they are giving? They have given around 10 acres land for the agricultural testing. So we develop our sensors in the laboratory, and we deploy actually in the fields. So you can see these fields. So all these things are basically managed by the university, and for developing the sensor nodes and actuators, cloud services, currently the university is supporting all those things. So we have one more like objective in that, but I have not discussed here. Like our company is also looking for the remote solutions, like remote sensing based solutions for the agriculture. So one of my partner in this company, he is from the civil engineering. He is expert in the remote sensing. So remote sensing will give some data like, okay, this soil moisture is probably in this range. And if you have a sensor on the field, on the ground, you will get more complete and correct informations to take the correct decisions. So the facility we have, like we have the weather stations in the field, and other sensors we have for monitoring the plant, like the one thing is called canopy temperature. Canopy temperature is like the, for humans we have body temperature. So each plants have their canopy temperature. So if you know their canopy temperature, you will be knowing, okay, the plant is health wise good or bad. Okay, like your temperature rises, that means your health is not good. Similarly, if plant's canopy temperature is above the threshold, it is, the plant is sick. So we have the instrument to measure that. Then we have the instrument to measure the chlorophyll content in the plant. Okay, instrumental conductivity. So these are the some high-end equipment we have, and we measure the plant health with that. And we have NPK sensors to measure the nitrogen, phosphorus. These are the basically major nutrients. Other nutrients are also important, like carbon and others, but those are not as important as the NPK. Okay? These are some of the companies in the agri-tech domain. Okay, so like these company I encountered when I took permissions from the university. So they asked like, what are the other companies in the agri-tech domains similar to you? So one giant is the Geocracy. This is basically launched by the Geo only. They are giving solutions and at very cheaper rate. So if you want to compete with them, you have to very innovative. And the others are like not very big, like Cropin. These are 10 years old company, Cropin, DHeart, Seeds to Market. So these are basically targeting on the fields. Many other agrotech you will see, like those are basically on the software level, developing some applications, mobile applications for the farmer needs. Okay, and some app-based solutions. But really, if you go to the farmers' villages and you do survey, then you will see like how many percentage of farmers are actually using the smartphones. Okay, it is not like I am farmers I'm using, but I also have to go to the fields. Like this, some of the farmers' son or daughters, they're using a smartphone, but they are not actually going to the field. The actual farmer who is going to the field, mostly they are not using the smartphone. So you have to think in the mind that if you are developing some solutions, that can be used by them. So for that, we did a survey in our nearby villages in our university. So we talked to some of the farmers, and they are ready to allow that we can install our sensor nodes in their field, and they are ready to cooperate with us. But they ask like, if any damage happens because of our sensor nodes, then we have to pay them. So how we decided like how much we have to pay? So we asked like, what is your previous yield? And if you use like our technology and our suggestions, then if your yield decrease, then we will bear the balance. Okay. Otherwise, if the yield is more, it is yours. We are not going to take anything. But that's disturbance should not be because of the natural calamities, or like hailstorm or something happens. So suddenly your crops, like your complete crops damaged. So that we cannot control. But like we have solutions for managing the water requirement. So because of that testing, if some yield decrement happens, we have to bear. Because if you apply for government project also, they ask like whether you have prototype and you have some applications on ground or not. So we can say that we have field laboratory, but field laboratory, they can easily say it is controlled and it is within the premise of the university. So you can say anything. So whether you have tested something on the actual farmer's land or not, because farmers, they they won't say like in your favor. They say if there is some profit to them, like profit in terms of like some yield margin or some increment to their income. Okay. So with this, I would like to thanks. So if you have any questions, you can ask.
Thank you, sir. Participants could please ask their queries.
Hello. It's not working. So my question is, this IoT technology in agriculture, basically it has two things. Like it is very complicated. I'm talking in terms of the farmers level. It is very complicated to them and it is very costly to them. So I just wanted to know how we are going to make it feasible in terms of complication and the cost.
So like first of all, like if you say feasibility, so farmers are basically resistant to use any new technology. So for feasibility, like government intervention is required. Without that, the farmers won't use. And costing wise also, like if you offer a 5,000 rupees product, even though the selling is difficult, so they want like something subsidized by the government. Once the farmer start using it and they see the merits, then you can commercially sell. Otherwise, the government intervention is needed in that. So all these agri-based any companies, if you see, there is always government backing. Otherwise, you cannot directly sell anything to the farmers because farmers are very reluctant to that. They think that if my job is going on, why should I use this new thing? Like if you tell them, for a simple example, irrigation. So one is flood irrigation, where you just put a pipe and flood. There is one drip irrigation. So if you ask them to apply drip irrigation, they won't pay. Because even though they know that if drip irrigation will be used, the water wastage is heavily reduced. But they think, why should I worry for the water? So government distribute the drip irrigation system in a subsidy. So in agriculture, like you cannot directly commercialize if you are working anything on the field. Other sectors which I shown the first next second slide, there you can directly commercialize because that is not, you are not directly dealing with the farmers, you are dealing with one layer above the farmer. So there you can directly sell, but if you want to deal directly with the farmers, you require some help from the government.
Thank you, sir. Any more questions?
Sensors mostly some voltage, analog voltage, like 20 millivolt, 30 millivolt. So what that voltage doing to you? So you read from the data set, you have to calibrate. So sensor is safe, but calibration is required for different types of soil. Different weather conditions, so that you have to know in advance. Like if you are using a wheat crop, so at which stage the wheat is? Like at the end stage, like you can see at the harvesting time, you don't require moisture. So you should be knowing that okay, at the harvesting side, the moisture should be 10% or something. So this is something you have to gather from the literature if you are not aware. Or you have to first study about the crop sensors and other technological point of view. He said.
One last question, please.
When we test in a lab, we have very less area. When we go field, we have large area, so we need to manage multiple sensor or we need multiple reading.
Sensor nodes.
Okay.
And then you transmit the data to one central coordinator node, transmit the data from there to the cloud. So depending on the area, different sensors, sensor nodes.
So when we use different sensor, multiple sensor, then the cost will be increased.
Yes, so land is also huge, large. Area is also large, so obviously cost will be increased. Like if this much area you want to map, you require 5 sensor nodes. If you want very accurate, or 3 sensor nodes you can cover. So according to the land areas, the cost will increase. If your land is huge, you have to incorporate more sensor nodes. So government is also like giving subsidy to the small scale farmers whose land is small in size. They have different benefits, and if your land is larger than certain range, then the benefits is different.
Thank you.
सर ऐसा होता है जैसे अपने सोइल होती है उसके हर जगह अलग अलग टेम्परेचर होता है, तो ये सेंसर कैसे वर्क करेगा? मतलब अगर सपोज दैट यहाँ पे टेम्परेचर अलग है इस प्लांट के पास, और अगर थोड़ी ऐसे आधा किलोमीटर दूर जाके भी अगर टेम्परेचर देखें तो बहुत डिफरेंस होता है सोइल में, तो ये सेंसर कैसे वर्क करेगा? कौन सा प्लांट कैसे वर्क कर रहा है?
See, sensors actually measures the temperature, the moisture at the point where you place. And if you talk about the temperature sensor, so temperature sensors basically there are two types of temperatures you can monitor. One is the ambient temperature and another is the soil inside temperature. So both temperatures are equally important. So even half an hour, half kilometers away, the temperature may be different, but sensors is same. So if different temperatures, different conditions, then you have the knowledge that okay, half a kilometer away, the moisture level is different. So I have to irrigate or not to irrigate.
Thank you, Dr. Rohit Singh, for an enlightened session. We are grateful for the time and efforts you share with our IEEE community. I would request Professor Saibal to present an honor to the MC. So please. Thank you, Professor Singh. Thank you, Professor Mukherjee. Now, moving on to the last talk of our plenary talk session, I would like to Mr. Chandrababu, CEO and Contact L2M Innovations Private Limited. Let me share a short bio about Mr. Chandrababu Patel. Mr. Chandrababu Patel is the co-founder and CEO of Contact L2M Innovations Private Limited. He is the chair of the IEEE Student Chapter and the current chair of Census Council Student Chapter at IIT Law. His senior IIIT Jabalpur in 2017. He is currently pursuing the PhD degree with the Department of Electrical Engineering IIT Law. Recently, he has been the Empress PhD Award for his work in sensors devices. His current research interests include synthesis of transition metal material via CVD metal oxides for process applications. I will request sir to please continue with the session.
फोल्डर में वो दो किसी में तो बजट के साथ
एक सेकंड वो आपका वो निकल गया यार, वो
स्पीकर दे दे बस
स्पीकर भाई दे दो।
माइक दे दे
ये वाला
स्पीकर हाँ very good morning to all of you myself very good morning to all of you myself Chandan Patel and I am from Contact L2M along with my team member Professor Saibal Mukherjee, co-founder and director of Contact L2M, along with other team member Dr. Pallavi Mukherjee, co-founder and director of Contact L2M, and Mr. Mayank Dubey, he is also a co-founder and director, and Mr. Sumit Chaudhary, co-founder and director. So before starting my talk on IoT-based solution, first, actually, as Dr. Singh has presented well related to the sensing node, so I'll not cover in detail related to the IoT sensing node technology. So I will directly come to the developed products, which were developed by our Contact L2M and related to their applications in different domains. And so now I comes to the background. So first I will cover the gas sensor technology, which were developed by Contact L2M. And so I'll briefly cover this, the background on this gas sensor technology. So as we are very well known that air pollution is become a major and silent threat in front of human community, especially NO2, H2S, CO2 and other gases, which causes various diseases in the past as well, such as Bhopal gas tragedy and Visakhapatnam gas tragedy were happened. And so therefore detection of these toxic gases at a ppb level is very crucial. So and yes, we follow report of World Health Organization. Every year approximately 7 million people lost their life due to the air pollution. Now come forward, and so now I'll talk about the limitation of the existing solutions which are already available in the market related to the gas sensor domain. So first limitation with the existing solution is the poor selectivity related to the particular gas which you are actually targeting. If you are targeting NO2 gas, so that will be the cross interference with the existing of other gases in the atmosphere. Second major limitation is associated with the existing technology poor sensitivity. So these existing sensors are not suitable to detect the particular gas below the ppb level actually. Which is very crucial to actually for the real-time application and as a biomarker application in medical sector actually. Another disadvantage associated with the existing technology is unavailability of real-time monitoring facility. It means user will not get the alert as well as the real-time data from the sensor. Another disadvantage associated with the existing technology is actually high operating temperature. It means existing technology is actually using the metal oxide based gas sensor. Metal oxide gas material actually requires certain temperature to actually to work at to get the higher sensitivity. So this particular temperature, to maintain this particular temperature, required a certain additional circuitry. That actually the another drawback associated with the existing solution. So what we have done actually in our actually startup, we have worked on quantum sensor, and these quantum sensors are developed related to the 2D TMD material. As actually our first speaker, Dr. Susil sir has already well explained related to the application and advantages of the quantum material. So I'll not cover here. And these quantum sensors or quantum material are actually sensitive enough. These can detect the single particle, even among the billion particles of a particular. So these sensors can be helpful for disease biomarker, for asthma, lung cancer, and other diseases. And these ultra sensitive sensor will also provide the ultra selectivity. It means these materials, quantum materials, are highly selective towards particular gas. If I talk about just for example, or for instance, if I talk about MOS2, it is highly selective towards the NO2. Now I move forward, and this quantum material work at the room temperature operation. So requirement of additional circuitry is lost there, and no additional circuitry will be required. Cost of the system will reduce subsequently, and power consumption will reduce, and the sensor self life will increases. And our developed solution will also provide the IoT-enabled portable solutions, which provide the real-time and remote monitoring facility, as well as the call, alert, and GSM facility. It also provides the past exposure history, and it is battery-directed and solar-driven module. So here is the actually developed gas sensor product by a Quantec L2M. So it is developed by for NO2 gas. Now, so here is the synthesis or deposition of monolayer MOS2 by a chemical vapor deposition technique. So I'll not cover in detail. So this is the actually process for the deposition of a particular sensing material, which were actually used in our laboratory using a chemical vapor deposition system. And we got the uniform and large crystalline sensing material, and validated by further experiment. So these are the further experiment we have done for the validation of our sensing material, AFM, Raman, PL, XPS, to actually investigate the property of the sensing material. It is actually pure, crystalline, or uniform in nature. So all these properties are investigated by these experiments. After that, this particular sensing material, which were actually developed or synthesis in our lab, transferred it on our interdigited electrode device. So as you can see on the optical image, there is the interdigited electrode device on a glass substrate. So we have transferred it on this particular device. After transferring the sensing material on the electrode, now we have required to package that device Because why we are packaging it? If we are directly using this device, the dust particles and other particle will directly actually after a certain long time will actually adsorb on the surface, and the sensing performance of the sensor will reduce. So that's why we have required the packaging. So first packaging step is the wire bonding process, because as you can see, we have done the metal lead wires are connected on the contact pad of our fabricated device, interdigited electrode device. And the packaging is done by a 3D printer, as you can see. And this actually packaging part is done by our actually packaging team. So BTech team members are involved here. So I'll mention in the coming slides. So packaging part, we have done the packaging by a 3D printer, and for the top portion or exposing area, we have used the mass, fine mass is there. So only the gas particles will in onto the adsorb on the surface, and dust particle will not actually come onto this. So this is our Contact L2M team demonstrating the developed NO2 gas sensor employing the quantum sensing material. So it is a single gas sensing module. Now, we have developed a sensor. Now we have required the readout circuitry or the complete product. So we have to integrate this particular developed sensor with the resistance readout circuit or the readout circuit, which will read the changes when the gas will come onto the surface of the sensing material. So what we have done the development of resistance readout circuit. It is the URC, Universal Resistance Readout Circuit. This readout circuit we have developed in 3 phases. First, on simulation, Proteus simulation is done. After that, we have done the breadboard analysis of this URRC. This URRC can measure the resistance change from 10 ohm to 40 giga ohm within plus minus 2% of error. And here is the URRC development on the PCB, printed circuit board, as you can see on the third picture. And we have also got the granted patent for this our innovation. So these are the actually other certificates for our development. We received the Best Technology Award from IIT Indore in 2023 and the MP Young Scientist Award for 2022 by Madhya Pradesh government. Now, after developing the readout circuit, now we have developed the sensor module, readout circuit. Now we have required for real-time monitoring, we have required the Android application. So this Android application part is developed. In this Android application, we have first, as I am talking about gas sensor, so this complete application provides the first user interface. User can edit the profile and change the password and other things there. And for gas concentration, it can measure the real-time gas concentration at a present moment by a clock, and it will also alert if the gas concentration exceeded in the hazardous range or toxic range. So by employing or by using this app, user can get the information for past exposure history of gases from daily basis, weekly basis, or on monthly basis. Generally, it is required in the industry. When we employ these sensor in industry, they have to require the real-time monitoring of the toxic gases. This and developed Android app is in multi languages. Currently, it is in 4 languages: Hindi, English, Tamil, and Telugu. And so these are the 3 phases of the development of Android application. After developing these 3 phases of our product, now comes to the integration part. So here we have integrated the GSM module for the remote alert facility. If particular gas concentration exceeded in the hazardous range, our developed product will provide the actually call alert facility to the user who is somewhere else, it not present on the particular location. So this product will call immediately on the user's number. Multiple numbers you can store on the SIM, and it will call immediately and repetitively if till now when the user is not responding. So this is the complete developed first product. As you can see, QGS1, quantum gas sensor first, quantum gas sensor second. So these are the QGS1 and QGS2 developed sensor here, as you can see on the screen. So here is actually one small video related to the gas sensor. So I'll not play, I think if I'll play, I take more time. So I'll quickly wrap it. I'll play other 2 videos which are more crucial to this. So, okay. So, okay. So now we have developed a gas sensor, but actually after developing a gas sensor, we have to require the calibrate our gas sensor. How much ppm it can actually sense, how much temperature it can operate, and in particular humidity, how it will behave. So this is the sensor calibration we have done in our dynamic flow gas sensing setup, which are available in our lab. So we have first actually validated our sensor with varying temperature range from room temperature to 300 degrees centigrade, and with different ppm of a particular gas from 100 ppm to the 100 ppb level. And we have seen the response of our sensor. And for further validating our sensor under varying humidity from 75% to 97.5% relative humidity, after, as I have mentioned that it is highly selective towards NO2, so we have done the selective analysis compared to the other interfering gases such as H2S, SO2, and other CO, methanol, and ammonia gases. We have also calculated the selectivity coefficient for our developed sensor. And when we comes to the LOD and LOQ part, these are the limit of detection and limit of qualification, which can our sensor detect actually efficiently. So it is in 1.4 ppb and 4.6 ppb with a linearity constant is 0.9842. Now we comes to the transient performance, how quickly it can actually sense. So response time is 1.45 minute. It can and recovery time is 1.5 minute. After that, we have done the repeatability analysis. So here I have shown only the 4 consecutive cycles, but it has done for more than these cycles. Now I come to the challenges which we were faced during the development of these actually gas sensor. So first, actually here I have highlighted the material challenges or the fabrication of our quantum material which were faced during these challenges. Second, challenges which were actually depicted here for the layout designing, and third related to the programming and packaging as well. Now I come to the competitive market. So here actually I have depicted the 3 major companies which were actually leading in the gas sensor domain till now: Sengbe, SGX, and Figaro, and compared our product with these renowned companies' product. So here is the gas sensor module with the existing gas sensing module in by a different company. So our developed Quantec sensor can detect the detection range for our developed sensor is 100 ppb to 100 ppm, and it is LOD is 1.4 ppb, means limit of detection. It can detect this particular concentration as well efficiently. Operating humidity, as I have mentioned, that it can measure it can sense the gas even higher humidity as well, 97% relative humidity as well. And cost we have approximated till now is actually 1,500 rupees, but it is excluding the electricity charges, taxes, manpower, and wholesale price. We are not actually included in this calculation. Now, after wrapping up the gas sensor development of gas sensor product, now I'll come to the biosensor product. So here is the IoT enabled biosensor for uric acid monitoring. So here is the background of uric acid in blood, actually human blood. So this is a hyperuricemia and hypouricemia conditions. And this hyperuricemia condition, if the uric acid concentration in the blood goes to above 7 milligram per deciliter, then these different diseases actually cause. And in the case of hypouricemia, these are the diseases. So now we have developed a solution for the real-time actually uric acid concentration or detection in the human blood. So this is our developed IoT-enabled product for the uric acid concentration in our human blood. So this is IoT-enabled biosensor which can detect the uric acid concentration in the human blood. So here, as you can see on the screen, the detection actually range of uric acid concentration we have tested from 10 micromolar to 100 micromolar. And for selectivity, we have actually tested for the ascorbic acid glucose with respect to these interfering actually or presence in the blood. And we have developed an Android app as well for this developed product. And it will provide the real-time uric acid monitoring in human blood, as well as it provide the digital receipt of a doctor. So that the receipt directly can send on the patient number. So this is the complete actually real-time demonstration of our developed product here. So I'll play one small video. So this is the actually developed uric acid product. So this is the actually sample cleaning. This video is cover actually the whole from the sample to the sensing material preparation and other things. Actually, we have covered here how we have developed the sensing material which can detect the uric acid concentration. So this is the first is the deposition of sensing material. Now this is the transfer process employing for the transfer of on the device or sensor. This is the sensor actually Now we have first validation we have done on breadboard. So this is the breadboard and PCB fabrication, layout designing. Now actually the soldering part and packaging, 3D packaging. So this is a complete kit of our developed uric acid sensor. So this sensor actually is in clinical trial phase. So this is the real-time testing for different concentration of uric acid. So these are the 3 products evaluation, as you can see. Now this product is in clinical trial. So this clinical trial is done at AIIMS Bhopal. So these are the blood or serum samples. So for our development, so as you can see the current changes according to the concentration of uric acid in the human blood and serum. These are the developed Android app which will provide the real-time monitoring and demonstration of our product in front of the AIIMS Bhopal team. So this is our Contact L2M team. And these are the other teams for web development, product development, and promotion and social media handles. And I really thankful to all the members actually who are contributing for this innovation. Now I come to the agriculture sensor. So as actually Dr. Rohit sir has well covered related to the agriculture technology. So I'll directly come to the development of our product related to the agriculture sensor. So as we know in the background, from the 19th century to the 20th century, the population dependent on the agriculture has increased. So now we have required to enhance the crop yield. So as you can see here, actually the why IoT is required in the agriculture. So it is
Sorry to interrupt, sir. We have 10 more minutes.
Okay,
so you
I'll
can
finish it.
please
Okay.
wind up.
So now actually in the IoT technology is required to in drone, soil management and livestock management, precision farmings, and these things we can improve by enabling the IoT technology in our product. So these features I have already highlighted. Now I come to the development part of our agriculture sensor. So this is the PCB layout designing and the integration and mounting other things and the packaging. So this is the packaged agriculture sensor, as you can see, along with the developed Android app. This Android app not only provide the real-time monitoring of the soil fertilizers or NPK concentration, pH, humidity, it also provide the disease detection by a machine learning. So you can actually take the real picture of a particular crop. It will actually detect the disease, which particular disease is there, and at which particular stage is there. And it will suggest the commercial and desi solutions to the farmer. And you can directly click on it, and it will provide the the solution which is available there. So this is the development of app. First, this disease detection. First, actually, we have developed for potato crop. Now I move forward. This is our Contact L2M website. So you can visit there and you can see the products highlight there and other things there, award and recognitions. Now I come to the real-time demonstration of this product as well. So this is the, I'll take 1 to 2 minutes. So this is the developed IoT-enabled product, and we have tested in various locations in campus as well as out of campus. So in a campus cricket ground, IIT Indore, we have started from our home as well. So this potato field near the IIT Gate 1B, we have tested it. And these actually the development of product, now guest house IIT Indore. And you can see the real-time NPK concentration. And now we have tested our product in UP as well, various locations in UP, because in UP is now currently in trending, all of you know. So we have tested in various locations in UP, and this is our developed Android app, as I have mentioned it. So it will provide the real-time detection of NPK fertilizer. We got the recent media highlights. So these are the certificate and recognition from various agencies. So these are the 3 major products which were developed or providing till now, actually provided by the Contact L2M, gas sensor, biosensor, and agriculture sensor. And we are currently working on it to develop other product as well related to the IoT domain. So these are the recognition we got from the various agencies, as I have mentioned it. And these are the funding initiatives. This is a Contact L2M team. So thank you very much.
Thank you, sir, for an enlightened session. Any queries? So no queries?
I have actually already received the gifts, so don't worry. I have already received the bag and other things from the sir. So okay, thank you very much. Thank you very much for all of you.
Thank you, Mr. Patel. So now we come to the end of the plenary talk session. Now we'll move for the lunch. I would request the participants to please move for the lunch. And after the lunch, we have divided the students into two groups for SIC lab visit, industry visit, and field visit. And everyone, please throw your packets outside the hall in the dustbin. The coordinators will help the members to join the lunch. Thank you, everyone.
So, hello. Uh,